Why do we need to study probability and statistics to build machine learning models? Where exactly do we use it? Let's see. So real-world phenomena are filled with uncertainty and randomness. For instance, the data sets that we have are often incomplete, or they could be buggy, and there could be some discrepancies in the data that's recorded, or the data could be biased, reflecting societal biases that people have when they generated the data. How do we deal with uncertainty in real-world phenomenon, and how do we make sure that the data that we have is representative of the actual data and the models that we build are relevant and useful to derive meaningful outcomes? So probability and statistics can come to the rescue to provide some tools in this context. Let's look at how probability and statistics can be used in different aspects or various stages of the ML pipeline. So during exploratory data analysis and pre-processing. So the data that we have was probably generated from some distribution. The problem is we usually do not know what this distribution is. But we can use some tools to understand this data better, the data distribution better. So things we typically do here are use the mean, variance, we look at the variance. We can look at the correlations between various features and the target. It can be used for engineering features. For instance, we could prune some features that are less correlated with the target. We can do resampling or changing the data distribution to mitigate biases in the data. For instance, if you have an imbalanced data set where you have more positive examples than negative examples, you can use some kind of resampling techniques. Or you could use some kind of playing around with the distribution to mitigate biases such as gender and racial biases, for example. So in order to do these things, it's useful to have some understanding of probability and statistics again, right? Okay, the next aspect is modeling. We can create models and infer with probabilistic tools. So there is a famous quote, I'm not sure who said this: all models are false, but some models are useful. So we can never be sure what the actual distribution of the data is. But when we actually build probabilistic models, what we are doing at the least is we are finding a probability distribution of the target variable instead of coming up with one value. So for instance, if I want to predict what is the probability of death for an ICU patient, it's useful to actually come up with a probabilistic answer. So basically I can say the probability of death is 0.8. That is more useful than saying will the patient die or no, coming up with a binary outcome, to see the simplest possible example here. So we can actually build many different kinds of model actually with probabilistic tools. There are broadly two categories: generative models and discriminative models that we see. So generative models are those models that actually try to guess how the data was generated in addition to just finding the probability of success or the probability of the target variable. The discriminative models are those that directly model the probability of the target variable as a function of the features. So examples of some probabilistic models are generative models are like naive Bayes classifier or Gaussian mixture models that are used for clustering, or hidden Markov models for time series problems, or there's Bayesian deep learning. We won't go into that. So examples of discriminative models are like logistic regression, that is very popularly used, or a lot of deep learning models like the feed-forward network, where you have a sigmoid with cross and softmax with cross entropy loss at the end. So that's an example of a discriminative model. So once again, we can build models and predict the probability of the target variable using probabilistic tools. Handling uncertainty. So when we actually use the ML models in production, for instance, how do we know if the outcome of our model is good enough to use? So suppose I'm trying to build a model in the context of a self-driving car, and my model is trying to predict how far is the nearest object in front of me to figure out basically if I'm going to collide with something. Now, it's important for this model to know when it's sure about what it's predicting and when it is not sure. So it might give me an answer, but if the model tells me that it is not sure, I can actually fall back to a manual intervention, manual backup. So it's important to have some notion of how confident we are about our predictions. So one tool that we usually have is confidence intervals that we come across, where we try to say with 95% certainty, my predicted value is this much close to the actual value, right? And another aspect of handling uncertainty is Bayesian modeling, where we actually handle parameter uncertainty. So suppose I use logistic regression to predict the probability of a patient dying again. So one thing is, it's a probabilistic model. It's giving me the probability of death instead of just giving me a 1 or a 0. But how confident I am about the probabilities that I'm predicting. In other words, if I'm learning this model, I learned the parameters of this model, how confident I am of the parameters that I learned, right? So parameter uncertainty is another aspect, and Bayesian models actually can handle that as well. So probability in statistics is useful to make ML models more usable. Testing and deployment is another area where we could use tools based on probability and statistics. A/B testing is a super popular way of taking launch decisions. For example, suppose you are launching a new feature on your website. It's customary to not launch it to all your audience, but rather do some A/B tests where you have a null hypothesis or a control group where you do not release the changes, and then you have the treatment group where you actually release the changes, right? So the null hypothesis actually says that whatever improvement you saw, your revenue increment or whatever, could be due to the natural course of events and not because of your feature. While the alternative hypothesis is that your feature led to the improvement or the change in revenue that you saw. So A/B test helps us see what is the probability, like p-value tells us what is the probability that a change that you saw in your revenue or an improvement that you saw or a metric that you measured is actually because of the feature that you pushed versus due to some other natural course of events. Right? So these are various examples of places where we use probability and statistics when we are trying to use machine learning to solve real world problems. There are, of course, many more examples that we can come up with, but these are some to just get you motivated why we need to learn probability and statistics for machine learning. Thank you.